So I want to demonstrate for you how you can do rotations. They take a little bit more than some of the other kinds of things that we've done so far, but not a lot. So I'm going to start by setting up an environment. So I've set a 600 by 600 drawing window, and I'm going to put a rectangle in the middle of the screen. So the upper left corner is in the middle, and it's a 50 by 50. Yay, there we go. So right there is the middle of the 600 by 600 area. Now, let's think about some rotations. Rotations happen in radians. I'm going to call those rads because I'm lazy. Radians go from 0 to 2 pi. You might be accustomed to thinking in degrees, from 0 to 360 degrees. But when we're dealing, it's often the case when we're dealing with rotations that we actually prefer to work in trigonometric units. So here we are. And I'm going to reset these to 0. The truth is that actually 2 pi is the equivalent to 0 in a rotational context. That's the same as saying if we rotate 360 degrees through a circle, 0 and 360 are the same. So later I'll actually delete this code, but I've written it, I'm going to leave it there. Of course, I have a global variable, so rads needs to be global. Now, nothing's happening because I haven't done a rotation, so let's rotate by rads. Nothing happens. So it turns out that rotate rotates things before they're drawn. So it essentially rotates the universe. So let's put that before the call to, oh my! Oh my. Okay, so this is what's interesting. When you do a rotation, it is a rotation around the 0, 0 point. So what's happening is I am rotating my rectangle around the origin, which is the upper left corner of the screen. And I'm going to scale the color by the range 0 to 2 pi, and we can see it starts at 0 and it rotates around to 2 pi, and it's all rotating around that upper left corner. Now, that is sort of neither here nor there. So we need a way to I want to rotate that in the middle of the screen. Oh, let's see. Not up there. Not up there. That's not where I do not want. Do not want. That looks like an orbit. That should have been called the orbit function. So what I need is to push a transformation matrix. There's a mathematical matrix that is where the linear algebra that does this work lives. It lives behind the scenes of all graphics systems. So what I want to do is I'm going to say that, imagine a stack of things on your desk. I want to put a new clean translation matrix on the top of that stack. And the first thing I'm going to then do is move the axes. So I'm going to take that 0, 0 point and move it from the upper left corner, and I'm going to stick it in the middle of the screen. Then I'm going to draw the rectangle as if it was being drawn around that 0, 0 point. Right, so instead of thinking of drawing it in the middle, the middle, because of that call to translate, is now the origin. The origin is in the middle of the screen. So when I draw my rectangle, I need to draw it with that in mind. So actually, yeah, so I'm going to go 25 up and to the left and 25 up. Oh, did I get it? Oh, push matrix cannot use push more than 32 times. That's because I just put stuff on a stack on my desk, as I said. So I need to actually pull things off that stack, and we call that pop matrix. So for every push, there has to be a pop. Now, I'm going to get rid of that code. It doesn't matter. Now what's going on is that I push my matrix, I translate the origin to the middle, I increment my radial rotation, I do some rotation, and then I draw my rectangle. And the result is it now looks like the rectangle is rotating around its center. All right. The last thing I have, so there's a push and a pop. If I want to draw another rectangle and somehow rotate it in a different location, I can do that. I push a matrix, I translate the origin to where I want to do my rotations. I don't know, I'm going to set some rotational value. I'm going to do my rotation, then I'm going to draw a rectangle, and I'm going to pop my matrix. I can try and translate again. I did this and then forgot that if you do any translation or rotation after drawing, nothing happens. So there we are. That is my second rectangle, and it is at 1/4 of the display. So that's the quarter point. Now what can I do next? The point of that is to show you can actually have more than one object. And actually I've just realized that my rotations are actually the same variable. So I'm rotating both things at the same amount. Like by incrementing them, I didn't have two variables, but I have two objects. So I'm going to change that. So there's rads1 and rads2. And I have to then also make sure I declare my globals. Oh, and I forgot to do that. So now I have two different rotational variables, so I can rotate both objects at different speeds. That's kind of cool. I can make them bigger. These would be good candidates for variables, I think. Whoa! Well, the reason that they just rotated there is because I didn't actually center the rectangles. So if I bump them so that when I change the size, essentially I didn't move the center. There we go. So now I'm rotating around the center of the squares. That's cool. I can change the rotational speed. I can slow down one of them. Woot. Very cool. Now what else? What else can I do? I think what I'd like to show you is how you can pull some of that code out of draw by defining a function. You've been doing this the whole semester by defining draw. Turns out I can define functions with any name that I want. So I'm going to take all my code for square1, and I'm going to paste it into a function called square1, and I'm going to take all of my code for square2. I'm going to define a function. Make sure never define a function inside a function. Okay. Def square2, paste my code. All right, there it is. And if I now, let's see, I'm going to need to declare rads2 as being global in that function. So if I say square1 and call that function, you've been calling functions all term by using rect and ellipse. I can, in my draw function, call square1. It will do all of those things. And then I can call square2, and it will do all of those things. Now check this out. I can add a parameter to my function. And that essentially allows me to add parameters down there. So now, when I change that value, and we look at the definition for square2, that 0.025 becomes the parameter rate for that function. Hopefully that, although that's moving pretty quickly, see there's rate, and then let's add something else. Although this is moving a little quickly, this is exactly what you do every time you draw a rectangle and pass in parameters for its location and its width and its height. I have just chosen to give my square2 function some new parameters. Here, I'm going to make it so I can also change the side length, not size, side. So I'm going to say I want to bump it to the up and left by half the side length, and then I'm going to make it length side. So now if I add one more parameter, that upper left square changes size. It's now 50 pixels. I can make it 150 pixels. I can make it 300 pixels. Okay. And that's because I changed the parameter for the side length, and my function makes use of it. I could try and change the side length of square 1, but we never added a parameter for the side length. So that really doesn't work. That's like when you get the wrong number of arguments or parameters for a call to one of the built-in functions.